So let's get into radiation. We have what are called isotopes. Isotopes are very simple, and you need to know what they are. Isotopes are just an element. So let's look at, I don't know, potassium, for example. An element with a different number of neutrons than you would usually find it. Sounds weird to describe, but it's that. So because it has an unusual number of neutrons, you get a little thing that says its mass is different, because when you change the amount of neutrons, you change the mass, because things responsible for mass in an atom are protons and neutrons. Electrons don't really matter. And so an isotope is just, yeah, it's an element with a different number of neutrons and therefore a different mass. So potassium 40 would mean that that's the mass of the isotope. Okay? So when it asks you in question 43 in your provincial exam booklet in Form A, June 2009, and it asks you which of the following are an isotope, and it gives you H2, it gives you plutonium, and it gives you potassium 40, like I just said, because I'm not very creative to come up with another one, and it gives you silver sulfide. Well, you know what is an isotope. It is an element with a different number of neutrons and therefore a different mass number. That's it. And for radiation, isotopes, because they have a different number of neutrons than normal, they are more unstable, and so they are more likely to react or decay or whatnot. Okay, so that's how that kind of leads into radiation.